What if your AI tools could automatically adapt their behavior based on who's calling them and what they're trying to achieve? You'll see how to inject FastMCP's context object into prompts, giving your AI-generated requests access to request metadata, logging, and even real-time user interaction, all while keeping your prompt functions clean and focused. The pattern uses dependency injection to make context available exactly where you need it, without exposing it to clients. From FastMCP, import FastMCP Context. MCP equals FastMCP. Name equals context demo. At MCP, prompt. Async def data analysis request, dataset, SDR-CTX, context, SDR. Generate a request to analyze data with contextual information. Hash context is available as the CTX parameter. Return F, please analyze the following dataset. Dataset. This demonstrates the context injection pattern for building stateful, interactive server components. The context object acts as an implicit dependency container, providing access to cross-cutting concerns like logging, progress reporting, and client interaction without polluting your function signatures. What makes this distinctive is its ability to bridge the gap between stateless function design and stateful execution requirements. The pattern works by leveraging Python's type hints for dependency injection, where the framework automatically supplies the context instance when needed. This creates a clean separation between your core logic and infrastructure concerns, while maintaining a declarative programming style. The context itself is request-scoped, ensuring isolation between concurrent operations while providing a consistent interface for accessing server capabilities. This approach solves the common problem of where to put shared functionality in modular systems. Instead of passing service objects manually or using global state, you get framework-managed dependencies that are automatically available when needed. It's particularly valuable for interactive workflows, long-running operations, or any scenario where your functions need to communicate with the broader system without explicit coupling. Let's break it down line by line. From FastMCP, import FastMCP Context. This imports FastMCP, the core class for creating AI-callable Python tools, and Context, which provides logging and progress reporting capabilities. These are the foundational components for building functions that AI models can invoke with proper execution tracking. MCP equals FastMCP. Name equals context demo. This initializes the FastMCP instance, the central orchestrator for AI-callable tools. The name parameter identifies this toolset in logs and error reporting, enabling better debugging across distributed systems. All tool definitions will register with this MCP instance. At MCP, prompt. Async def data analysis request, dataset, SDR-CTX, context, SDR. Generate a request to analyze data with contextual information. This defines an AI-callable prompt function using FastMCP's decorator pattern. The CTX, context, parameter enables logging and progress tracking, while the docstring becomes the prompt schema. All FastMCP tools follow this signature for consistent AI integration. Hash context is available as the CTX parameter. Return F, please analyze the following dataset. Dataset. This returns the formatted analysis request string, demonstrating how FastMCP tools use the context parameter for extended functionality. The CTX parameter enables logging, progress reporting, and tool chaining, while the F-string dynamically inserts the dataset name into the request template. This pattern ensures all AI-callable tools maintain consistent context handling. FastMCP Context Pattern. The context object transforms simple functions into interactive experiences, providing logging, progress reporting, and resource access without changing the core function signature. Context methods are async only, so your function must be async even if it doesn't explicitly await them. This pattern enables real-time client communication while keeping your business logic cleanly separated.
The context that knows everything forgets itself between requests.